Welcome to Hartman Math. This is lesson 3.6, square roots. So the first thing we've got to know is our perfect squares. So we need to know that 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, 16 is a perfect square. Keep going probably at least to 12 squared equals. Go ahead and pause here and write that list. Then the first thing we're going to look at is the product property for radicals or roots, which says that if we're taking the square root of a product, we can break that up into the product of the square roots of the factors. So the square root of a times the square root of b. We're talking about the square root of a times b. We're going to use that to simplify square roots, such as example number 1. Simplify the square root of 50. We want to break it up. We want to break it up such that one of the factors is in this list. And 1 really never helps, so we don't go there. We're going to start at 4, somewhere in there. So in this list of red numbers, which I refer to as the perfect squares, I'll call them red numbers. In that list of red numbers, which of those goes into 50? And we want it to be the biggest in the list that goes into 50. It's going to turn out to be 25. 50 is 25 times 2. So we're going to break it up that way. And I would always put, when we break it up like this, the red number first. So square root of 25 times the square root of 2. Start there. Then, what is the square root of 25? Well, because 5 squared is 25, that means the square root of 25 is 5. So we're going to write that as 5 root 2. And that's our final answer, fully simplified. So as I said, you do want to pick the biggest number that's in this list. 25 was the only one besides 1, and we never look at 1. But there's a couple that kind of get overlooked and missed. So I might highlight 16 in your list and 36 in your list. Because sometimes when those are there, people just choose 4 and they don't fully complete the problem. All right. You try this one, square root of 24, break it down, look for those perfect squares, pause here. All right, in this case, the perfect square that we're looking for is 4. So we're going to break it down to be the square root of 4 times the square root of 6. The square root of 4 is 2. So our final answer is 2 times square root 6. Example number 2, we might also have a number on the outside. That's fine. We're going to ignore that at the beginning and just focus on the square root 45. Look in your list of perfect squares, which of them divides into 45? Which of them is a factor of 45? It's 9. So we're going to go break that up to be the square root of 9 times the square root of 5. Don't forget the 3 that's in front. Then, what is the square root of 9? It's 3. There's already 3 out here. And this is implied multiplication. So 3 times 3. Square root of 5. And you could do that with a multiplication dot. You could do it with parentheses. Do not do it with an X. And then 3 times 3 is 9, so our final answer is 9, square root 5. I've got a big one for you here. You try this one. Couple different parts. Take your time. Pause here. So there's different ways of doing this. We can multiply first, but I think we're going to just kind of start simplifying right away. I think it might be the easiest way. So if we're thinking about the 18, that's going to be 9 times 2. 32 again, watch out. 4 is not the best that we could do on that one. 16 times 2. 16 is a red number. It's a perfect square. So we're going to break it up that way. And then we've got square root of 9 is 3. Square root of 16 is 4. So negative 2 times the 3, 5 times the 4. And with the numbers that are outside, we can multiply all those together. A negative 2 and a 3 and a 5 and a 4. Feel free to do that on the calculator. And then the ones that are in the roots, we can multiply those together as well, kind of taking that initial initial property for the product property, kind of working it in reverse. We can multiply them together underneath one root. So the square root of 2 times the square root of 2 is the square root of 4. Well, yeah, we know that one though. What's the square root of 4? That's 2. So we're going to get to negative 120 times 2. Our final answer is going to be negative 240. Make sure you show the work. All right, the other thing we're going to look at is the quotient property. So this is what happens if we're trying to simplify the square root of a fraction. We're going to break it up to be square root numerator over square root denominator. Such as example number 3, simplify the square root of 2 over 3. We're going to initially break it up like this, square root of 2 over the square root of 3. And then what we want to do is essentially fix the denominator. And throughout the course, that's going to be a kind of a common theme, is to fix the denominator. We do not want a square root in the denominator. So this is called rationalizing the denominator. And it's an easy fix. Whatever the denominator is, multiply the bottom, and then therefore the top, got to be fair, got to do it to both, by the denominator. If it's the square root of 3 on the bottom, we're going to multiply top and bottom by the square root of 3. Then on top, we're going to get the square root of 6. We can multiply those together. And on the bottom, we're going to get the square root of 9, which is just 3. So anytime you're multiplying two identical roots like this, square root of 3 times square root of 3, you would get 3. If it was the square root of 11 times the square root of 11, you'd get 11. Square root of 97 times the square root of 97, 97. So our final answer is the square root of 6 over 3. We no longer have a root on the bottom. No, we can't reduce this because the 6 is in a root and the 3 is not. So there's nothing we can do there. All right, you try to simplify this one. It's kind of already broken up for you, and the square root of 5 over the square root of 2. Pause here until you're done. All right, since it's already broken up, we're going to fix the denominator. We're going to multiply top and bottom by the square root of 2. So on top, we're going to get the square root of 10. On the bottom, the square root of 2 times the square root of 2 is, you guessed it, it's 2. So our final answer is the square root of 10 over 2. And example number 4. This one's kind of already broken up too. And we could do that. We could multiply top and bottom by the square root of 48. But I'm kind of noticing something. I think the 3 evenly goes into the 48. So one thing we could do is we could reverse this back to one square root of the fraction, as there's multiple ways of doing this problem. This is one of them. And then we could reduce this. What evenly divides into 3 and 48? 3. So divide top and bottom by 3. We would get the square root of 1 over 16. Now we can go back to breaking it up. Those are both red numbers. So we can take both of those square roots, and we're not really even going to have to fix this so much as just simplify. Square root of 1 is 1. Square root of 16 is 4. So there's our final answer, 1 over 4. Example number 5. This one kind of broken up, but it's just 10 on top, no root, that's okay, over the square root of 5. If this was reversed, I think we'd be probably fine and done. But we do have to fix the denominator. Always can't have a square root on the bottom. So let's fix that right away. Let's multiply top and bottom by the square root of 5. Now, as far as what goes on top, this is not in a root, this is in a root. So we're not really allowed to multiply the 10 and the 5 together since they're in different places there. So we're just going to keep it as is, as 10 square root 5. And then on the bottom, square root of 5 times the square root of 5 is 5. Or if we thought of it as the square root of 25, which is true, that's still 5. Now, in this case, 5 not in a root, the 10 not in a root, so we can simplify that part. What is 10 divided by 5? 2. Since we did it in that order, it belongs on top, which means there is no bottom anymore. We have no need for the fraction. Our final answer is 2 square root 5. If it had been reversed, if that had been a 5 there and that had been a 10 there, we would divide them both by 5 to reduce it, and then the 2 would be on the bottom in that case. The way this worked out, the 2 is on the top, so we have no need for a fraction. We're done. And that's it for today. I'll see you next time.